of data analysis, the NumPy, the Pandas, the Seaborn, as well as the Matplotlib. We haven't fully utilized them yet. What we have done though is that we did make use of Pandas to read the iris dataset into memory. So right now, having done all of that, renaming the columns, hey, we're gonna compare the same dataset which is provided for within Seaborn itself. Now, bearing in mind that I mentioned before the NumPy, which is, let's come back here a little bit, the version that we use, NumPy is version 1, so it's no longer in beta. Both Pandas as well as Seaborn are still in beta, okay, so 0.25 and 0.9, so they can, the actual API code that we're using like readcsv can change, okay, which is why just now the -1 threw out an error in the last lesson. But those are things to keep in mind. But again, usually the error message provide sufficient information for you to actually make correction or deal with the problem. Alternatively, I did show you how to actually go to Google, just search the error message, and then usually some kind soul has already asked the question in Stack Overflow to how to deal with it. Right, this is to show you under Seaborn, which we use SNS to denote that you can actually load the dataset. There are some toy datasets that's already been preloaded in Seaborn for you to actually make use of. So let's run that. So load dataset, we are looking for the iris. I'm storing it into the variable called iris, and let's have a look at the first 5 rows of data. And sure enough, as you can see here, the data already is straight from Seaborn. Looks similar but also different at the same time. You notice that the column name is a bit different. It's the user underscore to connect the two terms, sepal length, instead of what we use is actually just space. And the other one is that when it comes to the class, we call it class, they call it species, and they've stripped off the iris dash and leave it setosa, I think, and then the other two. But inspecting the raw data, it looks roughly similar. I don't think they're exactly the same. There will be some variation, but that's okay. At least from the surface of it, you can tell that they are the same data, more or less to a large extent. That's useful for the purpose. And as you can see here, that once somebody has actually kindly loaded the dataset, it makes it a lot easier for you to utilize it. So let's make use of dataframe.describe, which is a method that's provided for within the Pandas itself. So if you look at this, it describes to you that the number count, or count actually tells you how many rows of data that you have, is 150. Also gives you some basic information. Sepal length is 5.8, the width is 3.05, petal length is 3.75, petal width is 1.19. So these are descriptive stats, okay? Hence, it's probably why it's called describe. You have the mean, you have STD, mean towards standard deviation, you have the minimum, 25th percentile, 50th percentile, 75th percentile, and maximum. If you're not familiar with what I just said there, like mean, standard deviation, minimum, and or to maximum and the percentile, you probably want to refresh that. It's slightly beyond the scope. I assume that prerequisites of the foundation, that you already have those basic foundational knowledge. Otherwise, this course will just going to be run too long. But don't be too concerned with that. Just Google it. Most of the information are already online somewhere that you can actually quickly refer to it just to refresh yourself. But it's useful to know that. Okay, so this is the DF from what we had before, which is this DF here. All right, so if we look at the iris, which is from the dataset is from Seaborn, let's have a look at the describe, and just to compare, are they vastly different? So looking at it broadly, they look almost the same. Okay, almost. I say almost because, yeah, they have 150 rows of data, but I do notice that the sepal width mean is a bit different. Okay, and this, yep, likewise the petal length is a bit different. The petal width is a bit different, and some of these are probably because of the treatment of the data. And once you actually go down the track of learning machine learning and data science, you will very quickly come to an appreciation that the data are usually very dirty. Yes, dirty. Okay, there are a lot of manipulation, cleaning, sorting, munging that you have to do to actually get into a steady state whereby you can actually properly analyze it. But for now, I just wanted to highlight to you that despite the fact that they are two same data set, there are some variation. Okay, the DF, which is the data frame which we install or imported from Pandas itself, using Pandas to import it, the raw data set is directly from the UCI machine learning repository, and Iris, which is of course from Seaborn, and likewise Seaborn actually extract this directly from UCI as well, because they're all from the same source file, which is Robert, what's his name again? Robert Fisher. It's all from the same source, but somehow along the way something changed. So that's really to actually give you a rough idea and just an appreciation that these things can and do happen. So moving on from there, I just want to illustrate to you that you can actually use this method called info, and I'm going to print it to the screen. It gives you some really quick summary information, like how many rows of data, the type of data. You have the length of width in the form of float 64, and species is in the form of an object. Okay, so keep that in mind. You have four floats 64 and one object. And I'm using slightly more advanced Panda features, which is grouping them. I'm saying the data frame called Iris, group them by the column called species, and using a chain method size to tell me the number of observations for those respective species that is in the data itself. So looking at this, we have 3 different classes or 3 different species, Setosa, versicolor, and virginica. Each of them have a size of 50, the count of 50. Okay, so that's the one part to keep in mind. And you can see that they are balanced, okay, 50 each, which is useful for the purpose of our exercise. Okay, so for that, I hope that you found that useful. Just to do a quick summary, what have we done so far with the previous lessons? We extract the data directly from UCI machine learning, already provided to you in the form of CSV in the data directory, and you read it using the Pandas read CSV method. Okay, that one there. And this lesson we cover how do you load the same toy dataset directly from Seaborn itself, and we make use of some basic descriptive statistics methodology or methods as provided for in Pandas in the form of describe, which allows you to actually have information very quickly in the ways of count and the ways of mean, standard deviation, and the percentiles, plus minimum, maximum as well. I just want to move on to cover visualization as well. Okay, this part is a little bit more on the complex side if you're not familiar with it, but just do bear with me. I just want to illustrate to you how you can actually very quickly conduct very beautiful plots using Seaborn for the purpose of analysis, and quite often a lot of these codes can be recycled. Right, remember that Iris is our data set. There are a couple of parameters that we can provide. There are a couple of parameters that we can provide. So let's run this cell. Okay, this is actually performing a pair plot. Okay, straight away I'm getting an error. Okay, user warning, the size parameter has been renamed to height. Please update your code. Okay, so that gives me the information, and okay, to replace that, run that again and wait for that cell to finish running. We no longer get an error message, and we get this beautiful chart. Alright, it kindly also provides us with some color coding. Blue is Setosa, this is orange, versicolor, and green is Virginica. Okay, so very quickly you can see that this is in the form of a pair plot. Let me see if I can actually minimize this so that you can see the whole lot. Okay, not very ideal because it's a bit on the small side, but there are labels. The good thing is that you have your own notebook for you to drill in further. So I'm going to drill in a little bit now. This is, go back to 100%, this is sepal length, plotting against sepal length. So the diagonal is actually plotting against itself. When you're plotting against itself, what you see is actually the distribution. This is the sepal length distribution for setosa. You can see the setosa has the shortest sepal length. The versicolor and virginica, these two, is almost, you can't distinguish them in terms of their this distribution. Although for setosa, you can. Come to the width, yeah, barely perceptible difference there. Although you can see setosa is a bit slightly on the fatter side. Now these are distribution. Okay, what is distribution? Again, these are built upon statistical understanding and foundation for machine learning. You do need to actually refresh some of these basic principle and concepts in statistics. Basically, this distribution plot is kind of like plotting a histogram of all the possible data that's within the so-called variable itself. And in our case, if you look at petal length, you can see that setosa is much shorter in terms of distribution compared to the other two. The other two is almost, you can't tell. Okay, they're basically a lot of overlap. But for petal length of setosa, you can see that it's definitely shorter than the other two. Likewise with the petal width as well. So that's what the column or the diagonal actually tells you. Now if I plot sepal width against sepal length, this is the information that I have. It's a little bit hard to interpret, that's for sure. If I plot the, let's just say, petal length against petal width, I can see that the setosa zone is on here. There's some mixture, let me just blow it in. There's some mixture of the other two species here. There's actually intermix here, which is, you know, understandable. So this is a two-dimensional plot. This is a single-dimensional plot. So with this, I'm actually plotting the petal length to petal width here. And of course, that gives me a little bit more information as well in terms of how to distinguish them. This is really a very quick visualization to help you to actually get a preliminary understanding of the actual underlying data distribution, so that later on when you do machine learning, it gives you some foundations. For now, that's sufficient for what we actually want to do. So continue on, we can actually plot histogram as well. So let's just run this. And this is the histogram of the iris data for all four of the numerical data. So this is actually plotting, you can see the petal length, width, sepal length, and width. But this is actually combining all three species together, so you can't really tell which is which. It's just all the data is being plotted. Right, so the next one is actually plotting the Varlin plot. So we have 1, 2, 3, 4 Varlin plot, plotting the actual sepal length with sepal petal length width as well. And looking at these, it will inform you very similar to these pair plot here, except they're slightly different in the form of Varlin plot. You can see that the petal width for setosa and the petal length is definitely much shorter than the other two. If you drill into each of these, the white dot, that white dot there is the mean. And then you have the 25th percentile, the 75th percentile, that's the max, that's the min, and the actual distribution itself. there are a lot of information contained within the violin plot, so it pays to actually get comfortable with it as well. Next one is box plot. This is just really a quick illustration of the different types of plot that you can actually do with the Seaborn. So this is actually a box plot. Box plot basically looks kind of similar, or rather it actually displays similar information to the violin plot. So if I dig in a little bit and take this for example, the green line is the mean. Okay, this bigger box here, this is a lower quantile, upper quantile. Lower and upper is the 25th and 75th percentile. The solid bar here tells you the minimum and maximum, and this is for one of the species, which is Virginica, provided here. So again, box plot, this is grouped by species, so these are 3 different species here, so that's hopefully provide you with some useful information to actually judge. You can see that these 2 plots is actually sharing, in fact all 4 of them are actually sharing the same y-axis, 0 to 8. And you can see that this is actually squash, whereby this is distributed out. This is more squash, this is actually a little bit more widely distributed. So clearly the pedal width is actually much shorter. As you read these charts, just be mindful that they are not quite in the same model order. In violin plot, you can see the sepal length here and then pedal length. For this, pedal length is on top, followed by the sepal length. So they are in slightly different order, so just be mindful of that. Right, the next one that I want to show you is the scatter plot and also matrix. Similar information, probably not as useful as the pair plot. It does have its own place to display different information. Personally, I prefer the pair plot, partially because it's color coded. Of course, you need to provide the species to allow the hue to be generated as well. And finally, just as the pair plot again, but slightly different in that I want the diagonal to be a KDE plot, which happens to be the same as before. So that kind of like defeat the purpose. Well, you can actually change a different kind of plot as well. Do look up the actual API provided by Seaborn itself. So that's pretty much what I wanted to cover in this lesson in a very quick, fairly not really in-depth fashion. I'm mindful of that, but just the purpose of this is not so much to teach you visualization as the purpose of it is much more to illustrate to you what are the sum of the possibilities that can be done using Seaborn. You can see here that you can actually plot really beautiful chart, which is substantially harder to actually perform if you're using Excel. So you can perform pair plot using providing a couple of parameters. Likewise, you can actually perform histogram, violin plot, box plot, scatter, as well as the scatter matrix plot, and finally we'll come back to a pair plot again. So that's really a fairly quick whirlwind tour on what you can do with Seaborn.